Next we're going to talk about storage and disk considerations for MongoDB. Before we get into specifics, we're going to just talk a little bit about some of the basic differences between the sort of three main types that you're going to see. There's the traditional spinning disks, which are your standard hard disks, been around a long time. These tend to be take the form of, say, like the ephemeral disks in Amazon, or actual physical hard disks in an actual host. You've got network-based storage, be that a SAN, be that NFS, be that some other sort of network-based solution, EBS in the case of Amazon Web Services. The EBS storage layer is network-based storage. And then you've got solid-state disks, or SSDs. We'll be talking about some of the benefits that these have, but also the fact that they don't actually solve all problems. And we'll be comparing the various advantages and disadvantages of these solutions. Starting with spinning disks. Now, these have been around a long time, and as such there have been many scholarly papers, talks, discussions, descriptions of how they actually function and the various optimizations that you can use. I'm not going to go into all of that here. I'm just going to introduce some of the basic concepts and talk about how those impact MongoDB specifically and the common MongoDB data access patterns. So, excusing the crudity of this drawing for a second, imagine that this is one of our platters. So this is inside a hard disk. This will be a sort of a magnetic platter. There can be several of them stacked together, and this is what you hear spinning when you spin up a hard drive. This is what you can hear spinning around and spinning up, spinning down when you start a computer. This V here represents the head, and the head is what's actually going to read the magnetic bits off of this spinning. So let's just say it's spinning in this direction. The head will move backwards and forwards across the platter here in what we call a seek to get to the relevant track. So there's multiple tracks here, multiple tracks in this disk, starting with the smallest in the center, expanding ever outwards. You've got many tracks on a given disk. So how does this actually work in a MongoDB environment? Well, let's just think about the sort of the standard access pattern for MongoDB. And the standard access pattern for MongoDB would be to read a small piece of data from here, say a document, read another small piece of data from here, read another small piece of data from here, read another small piece of data from here. These might be documents, these might be indexes, but not necessarily going to be stored together on a disk. And you can imagine that this head that's having to go and read these things off the disk is going to have to bounce around quite a bit. And seek times, and this is a rather easy thing to find on the internet in general, you can just Google for the expensiveness of seek times. Trust me when I say in this context, seeks are very expensive relative to actually reading the data. The head here goes to this part of the disk, reads this particular document, and then we'll have to wait for this to come around to read this one. It's moving in and out all the time, and then this one will have to come around, then this one will have to come around. You get the idea. It's not going to be terribly quick. We're talking on the order of milliseconds here. Now there's a series of optimizations. These things have been around a long time, and there's a lot of smarter people than I working to make them more efficient. But you can imagine with a random access pattern as I've just described, that is not going to be terribly efficient for a spinning disk. Contrast that with the opposite example. So sequential access, this is what you'll see in most relational databases. This is what you'll see in some usage scenarios we'll get into in a second with MongoDB. And in this case, the data has been written sequentially in the same track or in adjacent tracks for this disk. So when the head gets to the first piece of data, you can then read the rest in sequence, and that's a nice and efficient way for it to actually read that data into memory, get it off the disk. So you can see how this sort of sequential access pattern is going to be far more suited to this sort of spinning media with the head seeking around. And the less you have to bounce around across this disk, and the less you have to wait for the data actually to get to the head and be read off, the better. So that's your spinning disk basics. There are plenty of well understood formulae for working out exactly how expensive a seek might be, given your data distribution pattern and exactly how big your files are, etc., etc. So you can have a look at that and dig into the theory if you wish. It's a little bit beyond the scope of this course, but it is out there and relatively easy to find. To bring it back to MongoDB, what use cases in MongoDB actually suit spinning disks? Where do we use and where do we see sequential data being written out and being read back? And the answer is two particular places. And those two places are capped collections, of which the oplog is one, which is used for replication, and the journal. So having a capped collection or an oplog on a spinning disk, or having other capped collections deployed on some spinning media, you're not going to see too much trouble. This is what they were made for. These will be sequentially written. The data will have good locality. They'll be able to read everything off in a single seek, or a minimal number of seeks. And the same is true of the journal. That's going to be your standard write ahead. Things are going to be written only on a particular piece of the disk, and they're going to be again sequentially written out. So those two things do particularly well in spinning disks. The alternatives to spinning disks tend to be quite expensive, right? We're going to talk about SSDs in a minute. So in a lot of cases, your spinning disks are your only reasonable option in terms of cost. So what we tend to do then is try to work around some of these limitations. We know that seeks are expensive, so the key to having a fast and responsive database, particularly when you're relying on spinning disk to back your data, is to have as much in memory as possible. Now that's true in any case. Even with the fastest SSDs, memory is still going to be an order of magnitude faster. But spinning disk, with the expense of the seek times and the bouncing around for various random access type access patterns, you're going to be particularly penalized for a random access pattern. So you want to keep as much data in memory as possible, particularly when you're using spinning disks.